Good morning, everyone. I would say good morning, early risers, because I think we're missing half of the room. Next time we'll try to start at 10. So welcome to this second day for this OntoCommons workshop. The idea of the session today is to provide an overview of the FAIR principles and to actually inform you of developments that are happening in Europe, that are happening in the GoFair Foundation, and also things we have been doing in OntoCommons. And we will start with a presentation of Professor Barend Mons. Barend is a professor, he's a biologist like me, actually. He's professor at the University of Leiden, started fundamental research on malaria research, and then the same as me, started to work with a lot of data, and so realized that he needed to become a FAIR data steward. And so he actually, worked a lot with graph ontologies, part of the biomedical domain package, I would say. He joined the FAIR Data Initiative and is actually the scientific director of the GoFair Foundation. And I will now give the floor to Barend. Barend, please, floor is yours.
Thank you, Yann. An honor to speak to you all. Sorry that I cannot be there in person. So I shall say a little bit more about myself before I start. Indeed, I'm a biologist by training, but in 2000 I switched more to data science and saw immediately the enormous amount of data that we are going to produce in the coming years. This is 23 years ago, of course. But also the enormous ambiguity in narrative language and how that led to a lot of troubles, like people in Uniprot, 70 people reading the literature to find out what people meant. So I became very much involved in machine actionable data.
Barend, I'm sorry to
Yeah.
interrupt. Can you speak a little bit more loudly? We have a hard time
Okay.
hearing you at the
Yeah.
back of the room.
Is it better like this? I can also.
Not much
Yeah.
better, but I think the audio here is not, you know.
Okay. I'll do my best to shout. Okay.
Thanks.
Then we in 2014 we had this paper, this meeting that you see on the first slide. I actually see it very small, but I know what the slides are about. Um, so on this, in 2014, we had a meeting in Leiden where we came together, and that is where the FAIR principles originated. And 2 years later, because it took a lot of time to go through all the nitty-gritty details of them, we published the paper on the FAIR guiding principles. And is it possible, by the way, to make the slides bigger? Because I see only one tiny little slide. Let me see how I can change that. Um, Wait. Okay, no, it's better. I already see them. No problem. So what we see is that this paper is now wildly cited. Actually, we will soon go over 10,000 citations. That's not to brag, but what it means, there is a lot of what I call pseudo fair. So people say, I have fair data, I'm going fair. Why? Because the funder is requiring it or something like that. And we see at the moment, and that's an important message I would want to give to this meeting. Some people I saw that will speak later do it right, but a lot of people do it wrong. And if people would say this is fair data, and then the goal that we do fair data for, the reusability by machines, doesn't work, then people say, you see, fair data doesn't work. So that is one of our major concerns at the moment and a downside of the paper. So the next slide gives you a little bit of an impression that some of these principles, I'm not going to go through all of them because I think most of you have read the paper. They have technical aspects. So you see the red parts here, give a globally unique, persistent, and resolvable now identifier. is a tactical decision you can make. And the other thing I would like to say here is that you see a lot of the principles are about metadata, and we have learned over the last 5 years or so that metadata are minimally as important to make data machine actionable than the data themselves. So the next slide will show you the green parts, that there is also a number of things in the FAIR principles that are clearly a social contract. So what is a persistent identifier? How long do you want this identifier to be unchanged? What is rich metadata? You know, those kind of things are a social contract you have to agree on in a community. And that is why we have spent a lot of time recently in the GoFair Foundation, but also in CoData, where I'm the president. We run the World Fair project. Some of you know it, I suppose, where we systematically go community by community to make a fair implementation profile, to make explicit what you mean by rich metadata in this particular community. You make a metadata for machine schema, and that is as important as following the fair guiding principles is telling the machine which choices you made. You can make a choice if you refer to genes, for example. You could choose the NCBI number of a gene or the EBI number. Doesn't matter for the machine as long as it knows what you mean. So the next slide goes a bit deeper into that. I now say always when I summarize FAIR, forget findability and accessibility as such, that interoperability and reusability means that the machine knows what I mean. And that really doesn't matter very much which thesaurus you use, as long as the thesaurus is renders machine readable data, of course. So this slide is really an important one, I think, to explain what FAIR is not, which is as important, obviously, as what FAIR is. So, first of all, people have a very strong underestimation what the persistence of identifiers really means. And there was this recent report that says that many of the PID systems that people consider persistent fail miserably. And you see some pretty important logos there who came up with this report. And that's why we have further specified principle F1 as saying every concept in your data, from a gene to a protein to an author to time date stamp, units of measure, whatever you use in your data, should have a GUPRI, which is a globally unique, persistent, and resolvable identifier, meaning that it always resolves to only one intended defined meaning. And that means that the machine knows what you mean. Even if you use a pretty remote identifier, if it resolves to the intended defined meaning, you're okay. So that's extremely important for this machine knows what I mean concept. But let me also go through 4 other major misconceptions about FAIR, and I wrote an article about it, Cloudy, Increasingly Fair, about a year after the article came out, and a lot of people cite it. But we always make the joke internally, and Jan knows Luis and the other people that are cynical, saying of the 10,000 citations, minimally half of the people that cite the article have clearly never read it. Okay, so there is a lot of pseudo FAIR, as we said. So first of all, people refer frequently to FAIR as a standard. It is not. It is a set of guiding principles to make your data machine actionable. Nothing else. You can use multiple standards to achieve that goal. And they could be different standards and different what we call FAIR enabling resources, like my example of NCBI versus EBI gene lists. As long as the machine knows what you mean, there's no problem. So that's why I hate language like unity of language, meaning that everyone has to use the same thesaurus, or that FAIR would be a best practice. I always say no, good practices. There are multiple good practices under FAIR that lead to machine actionability, and therefore we shouldn't talk about necessarily a best practice. There are multiple good practices, which is a crucial thing about FAIR. We don't force people to use exactly the same thing. The other big mistake that people make is to confuse and conflate fair with open. A lot of the doctors in my own hospital, I work in the Leiden University Medical Center, can turn away happily from fair because they say, oh, it cannot be fair. I have patient data, they cannot be open. So I have to tell them fair is not the same as open. The A stands for accessible under well-defined conditions, meaning that the metadata of your data includes the consent for reuse, which again leads to another very important thing that we will see later in fair digital objects, that the metadata should always be separated from the data, because I want to learn on the metadata how I can reuse the data. I would also like to know what the size of the data is. I would rather not download a petabyte of data, those kind of things. So we also say the accessibility is in the metadata, the arrangements, and the consent for reuse, but fair is not the same as open. The other thing that people try now is to water fair down to say, oh, okay, let's first make things fair for people. No, the entire article is full of references, if you read it again, if you read it, on machine actionability. And is a derivative, it is also very good for people because you avoid a lot of ambiguity because machines are very stupid. So you have to be extremely precise what you mean if you tell them something. And it forces you to get away from vague narrative language that confuses other people. And definitely machines look at ChatGTP, total crap coming out most of the time in between very nice text because the machines have no clue what you actually mean. So the last misinterpretation of fair, or the misperception around fair, I would rather say, is that it is for all data. We always say only make data fair. The first time you want to feed them to machines, many data need to be fed to machines, but a lot of legacy data, maybe never. And sometimes you can make data fair in the sense of reusable for machines without changing the data, but by adding fair metadata and instructions. I'll give you one example from our own hospital, well, actually in Rotterdam. They still used Excel. Well, you all know that's a deadly sin for data, but okay, doctors do not necessarily know that. And we got this huge Excel sheet from Rotterdam, and in column 108 it said naar huis in Dutch, which means gone home, which is a bit ambiguous when you talk corona. So we were joking with the doctor about it, but said if the algorithm that will analyze your data, we will talk about data visiting in a minute, if the algorithm comes to the data and the metadata tell the machine that in this particular station or fair data point, column 108 means discharge from the hospital, and here's the ICD-10 code, then the machine knows what you mean. So you don't have to change necessarily the data. You can make data machine actionable by giving very rich metadata, instructing machines how stupid the people were that constructed the data. So the next slide, sorry to spend a lot on what fair is not, but that's extremely important. So what we see about this hype term is that a lot of people that do not really believe in machine actionability will still use the term fair to get money from the funder, but they don't do fair. So the fact that it is also better understandable for people is a side effect, a wanted side effect. And we then also accept that people use the term fair as fully or federated AI ready data. That doesn't mean I believe that AI exists. I don't. But as soon as we create AI, we better have the data machine actionable and AI ready so that machines do not waste 80% of their power like we do on munching data before we can reuse them. So the next slide. I don't go into any depth here, but we are just starting a new institute, and I took this from a Nature paper, a recent Nature paper, and here you see what is reasonably done right now in the publication environment. That's the part that is above water of this iceberg, as you can call it. And we see that all the stuff that is underwater is still horribly underestimated, and there is still a lot of work to do. That's the only message of this slide that I just took from a recent management team meeting we had. So the next slide. Uh, Let me show you a little bit why we need fair data. Of course, we don't need fair data just for the fun of it or as a final goal. What we do in our institute is we use it for very, very complex biological problems, but you can use it also way outside biology, of course. I think half of the papers that cite the FAIR paper are now not on biology at all. Uh, but I think I have no time to explain this whole graph, but we say on the left-hand side of this graph, where you see solid, that's ontological information, the stuff we know, established knowledge. If you go to the right-hand side, the patterns are so complex that we don't understand them because we don't have enough understanding or compute power, CPUs, if you want to do it, that's the y-axis. If you stop adding compute power, so you're at your limit of understanding, your understanding of patterns goes asymptotically down to zero. That's where the complexity starts. That doesn't mean there are no patterns. We just don't see them. And that's where the computer is good at, to discover these patterns. But what do they mean to humans? So the red line you see in the middle is where I expect the immunome to be. And that's a huge project we are getting involved in. The ambition is to get 5 billion euros for that worldwide, to get all the omes of people from the genome to the exposome, but also all kinds of other data around human behavior, and understand better why people react to vaccines or not, and how side effects of drugs are coming on, and so on. So if you want to go very deep into what we perceive as chaos, and you know the statement chaos is order perceived by a lesser mind, uh, you want to discover very complex patterns, you better have machine readable data. Otherwise, there is absolutely no way to do this. And the other thing for which this is a bridge is that you need people, a lot of people from China, from Africa, from all kinds of regions in the world. And there is obviously no way that Chinese people will send their own data to the United States or the other way around. At the moment, it should never happen. And we have Vote on Africa, where the African people don't want to send their data to the United States as well. So we go from data sharing to data visiting. The data stay where they are. The algorithms go to the data. They analyze the data. They take the results with them. And for all that, you need fair data. So the next slide. Uh, Coming back to this you probably know this paper from Joachim Schulze and others. He's part of this project where you have the normal learning, the central learning that we all know, A and B. But if you go to federated learning, you basically send your algorithm to dispersed uh, repositories, and you never bring the data together. That is one thing that we already do, and it works like a dream. But now the next step is that swarm learning is even more advanced, where algorithms tell each other all the way through the learning process what they have learned in the blue station, and then what is there in the red station and the brown station. We still struggle with consent there because the level of consent that is matching with the question may change. But in any case, this slide is to remind me to tell you that data sharing in the classical sense, as in we send data to somewhere else, is over. That is only needed in less than 1% of the cases, and then it's probably mostly for legal reasons or whatever. You can visit the data and answer all scientific questions by distributed learning or swarm learning. And I think that is a really important other reason why the data have to be fair. That also is important for the pharma. I know that there's a lot of industry here and other industry. That is that you don't have to send your data outside the company, but you can make them talk seamlessly to data that are in the public domain, as long as both data sets are fair, because the algorithms can visit both at your discretion under your control. Next slide. Of course, it can only be done if we do this internationally. So here you see a slide where you see in the middle CoData, where I'm the president, GoFair, RDA, the core trust seal from World Data System. We work together as organizations on things like the Global Open Science Cloud, the World Fair Project, and we have a journal called Fair Connect, where we can publish very briefly about fair enabling resources. And on the left-hand side, you see something that I call the lightweight group of heavyweights. Is really a very informal group, but we met last week in Paris and it was very important again. That is that the leaders of the regional open science cloud initiatives, one of them Karel Luybe from the European Open Science Cloud, but also Xiamo from the African Open Science Platform, Jean Wei from China, they meet with the commitment to make all their regional open science clouds fully fair and interoperable. And therefore, we choose the thesauri that we want to use and the vocabularies for every semantic type, that's only 130 or so, across the world, so that we know that machines can travel all across the open science clouds and get the same result. My slides suddenly get small again. Oh, I'm back. Wait. Next slide, please. So I think I should probably quickly stop because I would like to get some questions. So here we go towards data visiting. And just to maybe end with the statement that this is not yet a dream or something that is very difficult to achieve, because in Africa, there's already 88 hospitals doing it this way with 9 fair data stations. And we have already shown that the small algorithm counting patients with COVID and stuff that is sent away from Leiden University to all the stations comes back with the exact same results as the same algorithm. Of course, for you, it's probably easy to understand. The same algorithm being sent from Uganda. And that is why we call the institute in Leiden the Institute for Fair and Equitable Science, because the other side effect of AI, quote, algorithms being sent around to the data rather than the other way around, is that these algorithms obviously are infinitely much lighter than the data. You can send them from your smartphone by 5G. Next slide, probably the last one. Yeah, so my plea is stop data sharing in the classical sense, start data visiting, and whoever is interested, send me an email. I will tell you what we are doing in Leiden in the new Pesthuis, a very old building where we bring everything together that deals with this type of technology in the midst of a bioscience park where we have organ on a chip and all the wet lab stuff. But we will fully focus for the next 10 years or so on distributed learning in fair data stations for both, biomedicine, agriculture, but this can also be done for materials. The FairMat in NFDI and other institutes are doing the same thing for any other discipline. So let me stop there, so we have hopefully some time for questions. Thank you.
Thank you very much, Barend, for this presentation and for kickstarting that session on fair principles for industry. Is there any question for Barend?
I see a hand on mic as well.
But I can't see who.
Yes.
So I see that Alex wants to ask a question. Alex.
Yeah, hello. Thank you very much for this insightful talk. So we're developing the role of the knowledge management translator. And basically what we do is we bring tools in, they can better whatever the organization is. And for these tools to work, we need fair data. They need to be machine readable, so we get the most out of it. So one of our ideas was to visit data. I like this term. I will nick it from you and cite you. To visit data, I need to make data presentable so the visitor doesn't get shocked. What's a good idea from your perspective to give into a first aid kit for such a person to help a company to make this data visitable? Because it's sometimes enough to do a little semantics to go a long way.
Yeah, very good question. First of all, you will never hear me using the term data management, because if people use that term, they usually restrict it to their internal data during a project. And what I talk to a lot of pharma companies now, some of them will also join this Lives Institute, anyone can join, where we have a training in what we call data stewardship. So data stewardship really includes this notion that in many cases, the data that you generate will be reusable by others than those that generated the data for a particular purpose, okay? And data management frequently is, oh, as long as my project runs, I have to take care of my data, but then I put them on the memory stick of my PhD student, you know? So the long-term stewardship of data is extremely important. We have fair enabling resources more and more in Fair Connect. And what we do as a Go-Fair Foundation, but we are expanding that very rapidly now to industry. We have several fellows from industry joining us right now to learn about this, because we are a small team. We have fellows that can join for a while. They can then train others, also in the company, and they can start making data fair, and at least fair metadata, starting with a fair implementation profile, metadata from the team templates. And obviously, if you've done that for DSM, probably Roche can use it as well, or rather, maybe Roche has done it first and then DSM. I know there's some people in the room who would know better which sequence was there. But this is what we need to do. We have to train data stewards, not only in academia, but also in industry. Industry loses a lot of money by bad data, of course. And the danger is, I won't mention names, but the danger is that there are companies that are now concluding large contracts with the pharma to make their data fair, and they mess up. And that will give fair data a bad name. So before you go into a contract with a company or a public sector environment that says that they will make your data fair, think twice or get your people trained so that they know what they're talking about. There's a lot of pseudo-fair. So data stewardship rather than data management, and train data stewards. My statement is, on every 20 data spitters, there should be one professional data steward. So 5% of your budget for research should go to data stewardship, roughly.
Yep. Thanks for the answer.
Thank you, Barend. There is a question from Sten. Sten?
Yes, hello. Very interesting and very clarifying presentation. I presume that you have developed infrastructures covering keywords and such to allow the data to be searchable by machines, and by that transferring the what we call the semantics or the human readable terms into numerical values in order for it to be more, and to support global implementation, because you can more or less have, you are searching on numerical series, you are not searching on regular terms, so to speak, human readable terms. Would it be possible for, what? Do you hear me?
Yeah, I think I understood the question.
Yeah,
but
the question is, could it be possible? Could you, if that is the case, would it be possible for you to maybe publish that approach to the other projects that are here, in a sense, because that would simplify for them to implement this to support language areas that are outside of the European Union?
Well, let me say two things there. First of all, the GUPRI is of course a handle and not a narrative term. Narrative terms, 90% of them are ambiguous, and certainly across languages, of course. So first of all, it becomes extremely easy that, let's go back to my old love malaria, that if you have the URI or the GUPRI for malaria under the hood, that the machine will put out paludisme in France. That's clear. So that, as long as you have made that mapping table, of course, but that is done, for example, for most of the terms in Medline and in UMLS and so on. And but going a little bit deeper into your question, it's a very important one. And Jan, maybe you should really discuss that later in a special workshop. Um, the the web of fair data and services, the internet for machines, stands or falls with this mapping table. And not only between GUPRIs and terms in language, that's one thing, but also GUPRI versus GUPRI. So there's multiple thesauri, like I gave the example of the gene list in NCBI or in EBI. It doesn't matter for the machine as long as it knows what you mean. So you need a triple saying GUPRI 1, also referred to as GUPRI 2. That's again just a triple. It should have an author, it should be a nano publication, an author and a time date stamp. So if a German person would say malignant neoplasms, also referred to as Krebskrankheit in Germany, and that's just a German saying that, that's one thing. But if then the Unified Medical Language System approves that nano publication or republishes it with the ORCID of the authoritative person at the National Library of Medicine, suddenly it becomes an official synonym. So the mapping tables between GUPRIs, different GUPRIs that can point to the same concept, and all lingual terms that are also pointing to that concept, is an extremely important core resource in this field. And that's why we propose two things. As I said, in the World Fair project, we'll go systematically with recognized experts communities through all semantic types. So we started with, I mean, that is CODATA, with units of measure, chemicals, people, ORCID, geolocation, and so on. That's what I mean by semantic types. Species, for all of those, there are usually already very good thesauri, but maybe you don't know. Did you know that GBIF, the Global Biodiversity Information Facility, has a beautiful thesaurus of 1.8 million species with their unique identifiers and a lot of information? Use that, please. So the fair implementation profiles that one community has made and made all these choices explicit on each of the semantic types that appears in their data can be reused by others. So if you, for example, go to material sciences or to the pharma, they can reuse each other's fair implementation profiles very easily because all these choices for internationally recognized vocabularies have been made. And in GoFair, we have people that happily translate these thesauri in other languages. So it also helps people to break across the language barrier. That's part of the equitable science as well. But these things should be publicly published in open access because all the organizations that maintain these mapping tables, they go through a near-death experience every 4 years because nobody wants to fund it. By publishing this as nano publications, we have a public record of these mapping tables, and it becomes very equitable across languages, jargon, and you can use different thesauri as long as they uniquely point to the same concept in your data. It's okay.
I just entered the text into the comments there that Barend can inform me later on if you want to.
Yeah, well, SNOMED is one of the trillion examples, but SNOMED has, for example, a big problem that people in Brazil cannot use it without payment. So people in Brazil won't use SNOMED, but it doesn't matter. There is many mapping tables for most of the concepts that are in SNOMED. You can also find them in other thesauri, and then you use one that you don't have to pay for. You have to be a member of the NLM in crowd, in a way, at least until recently, to use SNOMED. I don't know whether they changed that, But some of these tesori have a very expensive license, and people in the south cannot pay for that. So that's why we want to support multiple tesori rather than just one. Okay.
Thank you, Barend. So I'll take maybe one other question from the assembly, but I think that everybody. No, I don't see any question. So I would like to thank you, Barend, for your time and for this really nice introduction into the Fair for Industry session. I will now invite Martin Romacker from Roche, actually, because the idea is to now see, after what Barend said, how it's been implemented in industry. And in fact,
final word then, because
yes.
Yeah, Eric Schultes, Martin knows him. Just to give Martin a compliment and an introduction, when Eric came back from a meeting where he saw Martin present, he said, "This is the best fair talk I've heard outside academia, and it's probably better."
Thanks a lot.
No pressure on Martin, but I think they did a great job.
Thank you, Barend.
Can you hear me, by the way? I've switched on the mic.
Yeah,
we can hear you, Martin.
I think I still need presenter grants because I'm currently there as a guest.
Okay, so I think they will give you the rights to share, and that gives me a few minutes, for a few seconds, I hope, to give a short intro. So Martin is product manager at Roche Data Marketplace in informatics at Hoffmann La Roche in Basel. He has a strong focus on data strategy, data governance, and harmonization. His main area of activities are terminology management, semantic engineering, including knowledge graph, scientific data curation, text mining, and enterprise search. Martin has been actively developing and deploying data standards across all functions at Roche, and has been collaborating with external partners to ensure high-quality information procurement for data acquisitions. He has been heavily involved in the implementation of the FAIR principles in a variety of cross-functional, cross-site projects, also assessing the organizational FAIR maturity. And he has also been contributing to a number of pre-competitive engagements in the Pistoia Alliance and the Innovative Medicine Initiative. I actually met Martin briefly at the EOSC symposium in Prague in October, and I was actually stunned, as Barend was saying, to hear this really great talk on how they implemented the FAIR principles at Roche. And so now I will give the floor to Martin so he can impress you all. Thank you, Martin, for joining.
Thanks a lot. Can you see my slides as well? I've shared them. You see the slides? Yeah?
Yeah.
Yes.
Okay, thanks a lot. Yeah. Yeah, thanks for the introduction. In contrast to Barend, I have quite some slides as usual. So I'm going to start with the presentation. Yeah, a little bit, some thoughts about data economics, and then I walk you through the entire FAIR journey that we have seen here at Roche, Genentech, but also within the industry, with some positive and some negative thoughts about where we are stand as a community with FAIR. If I say as a community, I mean really not only pharma, but everybody who's contributing in the broader field of FAIR. So looking into the economics of data, I think there are currently this mega trends in digitalization, and this is a slide I've taken from Rick van Bruggen from Neo4j, that are well-known data-driven discovery. For us, it's data-driven drug discovery, personalization. In our healthcare sector, it's personalized healthcare, where you try to find the right drug for the right person. Enhanced decision-making, massive data integration, where you have different views. We have systems in medical chemistry, but also in the customer space, wherever. Last but not least, AI and machine learning. And the topic that typically gets neglected, and this is the elephant in the room or the blind spot, is that when you want to advance in digitalization, what you need in the center of everything is high-quality, connected data that is fully verified. In order to be able to do so, and I think Barend already gave a lot of interesting context about this, you have to work with data standards which apply to terminology, so the words that we're using, concepts, metadata, dataset models, and last but not least, ontologies that we use. So we internally talk a little bit about FAIR plus Q because we also want to bring the dimension of data quality into the game. Now, looking the way how I've been working, it's quite interesting that typically we just look into, say, the planned visible costs of generating data assets or data products, as we say today. So you need, of course, if you think about a clinical trial that you run or think about an assay that you run, you need FTEs to create the data set. You need all the material, the sample, reagents, compounds, the instrument and everything, the infrastructure, building, computers, machine. What you typically don't see is that because you're doing poor data management, I'm sorry, I'm using a data management, Barend, because you do poor data management or poor data stewardship, if you wish, there are a lot of invisible, unplanned costs downstream. You have to work with business analysts to recover information. You have to have huge ETL process engine, work on data cleansing, searching and assessing, data curation, semantic data integration, and all the FTE and infrastructure to really support these unplanned activities. And that's a very interesting point because people always say, you know, oh, it's so expensive to work on fair data, and is it really worth doing it? I think if you really look at the way how it's currently today, the contrary is the fact. The ways how we've been working, which don't look into fair, are ways more cost extensive, but people typically don't see it. So what we want to achieve also, and this is a little bit my vision, I think it's pretty much in line with what we've heard before, is to really come up with an open, public, private, semantic infrastructure of fully standardized, fair applications, services, and data. And in order to do so, at Roche internally, we have in a cross-site, cross-functional program, we have developed the so-called Roche Data Commons. That is a 5-layered abstraction layer. On the bottom, we have the infrastructure. This is where the data physically resides. Then we have the layer 2, where we manage the data, the scientific data sets. This is also where stewardship happens and normalization. And in layer 3, we have these harmonized data access points. And this is really a big change because we went from application-centric to information-centric. So a harmonized data access point is organized around a semantic type. So we have harmonized data access points for adverse events, for clinical study, flow cytometry, medical history, patient sample study, variants, vital signs, you name it. And then we use these harmonized data access points to really fetch the data, build our integrated data sets from this, and then finally, last but not least, we're building the analytics and the visual tools on top of everything. So it's a complete flipping of the coin. So we put data information in the heart of everything, and we build applications on top of data, and no longer vice versa, that we log data and applications, and we have to maintain a huge machinery to be able to do our analytics. And what ties everything together is something that you can see on the left side, is the reference data services, it's terminologies, the metadata, the dataset models, and the ontologies. So where does the actual verification happen? I think this is a point where I have a very strong hypothesis. So if you want to make your data fair, this has to happen at layer 2 and layer 3. So this is where, on the one hand, you do the data stewardship, where you assign the metadata attributes to your data assets, where you assign controlled vocabularies, standards, maybe like CDISC, like ODC, and so on and so forth. And the way how we expose it here in the harmonized data access points that also have their semantic model. This is where you then use the reference data services to bring in the GUPRIs, the URIs, the semantic resources. And layer 4 and 5 are only for dereferencing. So I have a GUPRI when I'm talking about a specific concept like malignant neoplasm or whatsoever. Then you use the GUPRI to dereference this object or this digital object. So now when at layer 4 and 5, you still have to work on heavy transformations, on heavy data integration, something went wrong with your data verification. So, but how do we know how fair our application services and data are? This is also where we have a couple of pre-competitive collaborations with other colleagues in pharma. And as we have also seen in the slide before from Barend, we have fair maturity indicators. We've created here a specific tool set with methods in the Pistoia Alliance project, which is called Implementation of Fair Principles in Life Science R&D. And here are the fair, some of the fair maturity indicators that have a star here. And something that I constantly have to emphasize here internally is that what is true fair. I think the issue that we are seeing with fair is that many colleagues, also in our organization, they take the letters in the acronym FAIR literally, F for findable. So I can find something, I'm fair. But fair is not only the fact that you can find something, it's very much about the how. And the fair maturity indicators tell you how this how should look like. And here we are bound for data and metadata to identifiers which are persistent and unique, so the GUPRIs. We ground our metadata and shared vocabularies, so we cannot take a greenfield approach. We are using community standards to represent our data and metadata, and also more going to the interoperability. When you're working with data, you have to use ideally in strict machine resolvable formats, and also vocabularies ontologies that are fair by themselves. I think this is something which is frequently neglected, and everybody thinks, or many people think that they are fair, but if you apply the fair maturity indicators, you see that they are not. So now looking into standards and the pharma industry, so we have a very simplistic view on fair. So I think there's a human aspect to it and there is a machine aspect to it. So fair for human means that you're able to find, access, and understand the data without the presence of the data owner. But more importantly, it's the ability for a machine to automatically find and semantically use the data. So it's really about not only about findability, but usability. And data are supposed to be machine actionable. So let me just give you a little bit some concepts about fair architectures and what is needed. What is the capability stack that you need to be fully fair? And I have here a made-up example with a table-like structure. And as you can see here in the red boxes, there are terms like male or female, and these are concepts that which have a globally unique persistent identifier. We have an own identifier space here at Roche, which has this ROX prefix. And of course, you find them in different areas. So this is the first level that you need to be able to present. So you have the lexical, linguistic dimension and the semantic dimension. So you have labels and terms, and then you have a concept. Then what you can also say is that if you take in one of these columns the set of all the different concepts that can occur, then you have a terminology. In this case, for example, it's the terminology about biological sex that has 3 values, male, female, unknown, and all the other ones here about age unit, substance name, or dose unit, same principle. But also these objects, they require resources. They are digital objects and they should have an identifier. So next level is that on top of these tables, you have something that people call, in the clinical domain, they call it variable. Also think about it as a data or a metadata element or a field name, a column header or whatever. But this is something that describes your data and it also has to be registered. Typically, we do this in a metadata and data element registry, forming a metadata catalog, and it also gets an identifier. Then you can see the schema, which is the set of all the identifiers defining this table-like structure here as a URI. And of course, in different spaces, you have different schemata. And last but not least, if you have such a structure, there is a kind of a brute force approach that people take to represent their data in a possibly fair-like way and create RDF out of it, where they simply take one column, in this case, for example, it's the subject identifier, as the subject of a triple. Then they translate the entity on the top into a predicate, and the value in the cell is then the object. So you make up your triples. But this is an approach that neglects that in between all of these various variables or metadata elements, you have semantic relationships like H value and H unit form together H, or this is an even more complex object here. And this is something that you can see on the next slide. So instead of just taking this brute force approach to create RDF, if you want to be fair and to have clean RDF, you need to provide an ontology behind it. And we are building in our, I have more examples around this in Roche. We're building purpose-driven ontologies that are in domains and data subdomains. There are also more architectural approaches coming in, like data mesh architectures that support this domain-centric view. And here you see that we have provided here a richer representation where you have a study subject that has a biological sex, but then the study subject also has an age that has a unit and a value. And then there's a more complex object here, which is a treatment that has a route of administration, which has a frequency of administration. And then you have a dose, and the dose, again, consists of the dosage form, the active substance, and the substance strength, which has a unit and a value. This is a way richer representation, and I would be very, very much in favor if these are what I would call information components, if we were able to standardize them across the industry and using them as templates, possibly publishing them in bioschema or schema.org. What you can do now is that you can take the values from the table and map them to the richer representation and create a semantic graph out of it. So looking into talking now about the beauty of semantics and the stack, going from terminologies to metadata elements, the schemata to true ontologies, I think being a practitioner, looking into the way how we manage our knowledge space, it is pretty ugly and pretty complex. Why is this the case? So go to a public resource like Fair Sharing and filter on standards. You will find today, by the way, 1,651 entries. But I've taken the screenshots about 3 years ago. So we still have a constant growth and proliferation of standards, which creates a huge issue. Just picked up another example where we're also working with some colleagues internally on talk, on the fair data points. And here you see, for example, internal representation that we're getting out of our clinical systems, where we have a survival status that has 2 values, alive and death. And then if you go into the fire representation, you see that they're using a completely different way to represent the same fact. So they use something which is diseased Boolean, and that's either false or true. So if you have this kind of divergence between standards, then you are back into the map and merge business, and you have to have ETL processes like if diseased Boolean false, then survival state is alive. And I think what we urgently need as a community is conversions on standards and conversions on how we represent these information and knowledge components. So, more examples. These are 2 different standards that we use in the industry. The left one is CDIS, that's mandated for FDA submissions, where we describe a patient in the demographics domain. And on the right side, you see a patient model coming from ODC, which is used in the real-world data space. As you can see from the representation, we are talking about exactly the same entity. We want to describe a person, a study, a patient, with different properties, like again the age, the sex, for example, and even though we are talking about exactly the same thing, the representation is completely different, and we have to invest a huge amount of work for mapping and merging to be able to create insights. So different models, different variables, and different values. And by the way, there are also misconceptions because sex, for example, is something biological. They're using gender, and gender is something which is social cultural. So ideally, they should not use a concept like gender. But I think baseline here is talking about the same object and then very different representation. I can go to another standard. This is DICOM. This is huge for this is huge in the imaging space. The DICOM standard browser. Again, here I'm describing a patient, different identifiers, different type of representation, different variables. This is really taking up a lot of work, and even in some cases, it's something that we cannot solve. So now, luckily, also as Barend mentioned, we are heavy into this identifier group remapping, and MBLEBI offers a service which is called OXO to provide mappings between ontologies. As you can see, it's already pretty overloaded here, overcrowded between all the different resources. And please bear in your mind that we are still constantly adding new resources to this that we have to maintain. So if you want to state it in a quite provocative way, is that we are allocating a lot of resources to inflate a problem by constantly creating new standards, new ontologies, new resources. And then we need to allocate significant resources to reduce the problem, where again, we have a huge loss of information and interoperability, because colleagues who might have been active in the ontology mapping realm, as I have been, know that it's not so easy to really determine whether two concepts are semantically equivalent, even so they may have the same label or the same linguistic representation. There's a quite interesting initiative going on, which I like a lot. It is this simple standard for sharing ontology mappings. There will also be a way, possibly besides nanopublications, to make these. I think you can put this in nanopublications if I remember properly. That you represent your ontology mappings in a standard. But again, quite interesting. This model for the ontology mappings is also, again, not fully fair, because they're using, for example, for the mapping date, which is the created date, not a standard. In contrast to many other colleagues, they're using this underscore type of writing. So instead of using community vocabularies to represent what they want to represent, they again craft their own standard. But I think this is the way, how besides this point, we need really to converge, and we need to make our content available in a way that is standardized and easy to consume and to integrate. And last but not least, I think we also have been living a little bit with this linked open data cloud, the linked data illusion. Why it is an illusion? Because I think that people do believe if two systems talk about the same entities or the same semantic types and everything, that the data are linked. Linkage comes with referential identity. So if you have either the mappings or you have the same entity, and then you referential identity comes with interoperability. And I think this is what we have to work on as a community. So now what we have built internally, this is a product line, which we call the Pharma Interoperability Hub, that exactly represents these three layers that I've mentioned before. So we have terminology management, we have a semantic metadata registry with semantic dataset definition, and conceptual modeling, which for us is purpose-driven ontologies. The products that we offer, following the FAIR principles, are themselves fair by design, supporting verification at scale. And we also ensure these semantic interoperability and high data quality. And we also do a lot of these GUPRI mappings on our side. The products are a reference data for the standardized metadata and conceptual models, as you've seen in the Roche data commons, where we semantically link internal and external data. And today we are supporting more than 100 productive applications across all Roche functions and sites. And last but not least, the technology piece is only 10–20%. And this plays into the data stewardship importance that Barend has mentioned. So we have a service behind this that really guarantees currency and ongoing support, both for the semantic infrastructure and the right application in the various data domains we are supporting. So here, just a small preview on the tool. It's all web-based. It's using a semantic technology stack. The terminology system here, for example, has so-called master terminologies where we govern and monitor everything. You can see it on the left side. This is our master terminology in the oncology space. I've opened up a concept like non-small cell lung cancer. On the right side, you see the rich descriptions with a preferred label using COS, COSXL, Dublin core, of course, a definition, all the different synonyms with the cross-references. And then we bring these terminologies into the application space by using name graphs. So we encapsulate for each consuming application, the terminology that they want to consume into a name graph. And then they can really customize the usage, and they only take what they really need. Second one is about the data dictionary, so the semantic metadata registry. This is an example coming from CDISC. On the left side, we have the set of variables coming from the demographics domain, like age, country, age units, date of birth, and stuff like this. And they're all harmonized, standardized, linked to standard, also with cross-references, GUPRIs, and then we can apply them again in a contextual way. So this is the harmonized data access point for subjects, where we have a domain describing the subject, as you've seen before in the example with OMO and CDISC. And here are all the variables. And what we can do in this tool is we can do the linkage, the group key mapping between, for example, OMO standard and CDISC where possible. And then when you, for example, you select or you define a metadata element like country, then you can also define, okay, I have country is a variable. It has a value domain, which is an application terminology that contains the set of all the countries with the ISO alpha 3 coding, single valued and additional information. Last but not least, we have here the place where we build the ontologies. You may ask yourself, why are these guys so crazy and don't use Protégé or Top-Rate Composer? The answer is pretty easy. It is governance. So we have a set of officially internally approved classes and properties that we can then use to build our terminologies. Here is a model here for the infectious disease knowledge base. And we have here classes like pathway or drug or tissue. And by doing so, we ensure that whatever model we create, whatever ontology we use, we always have the same globally unique persistent and resolvable identifier that we can then also, of course, we can export everything into Turtle and load it into other systems. But this really helps you to make your entire knowledge space fair by design and still maintain the flexibility in the data domains to model their purpose-driven ontologies in an independent way. So this is the stack. So at the bottom, you see terminology management, and we have the data set models with the master data registry, the conceptual model. And what's quite nice, when you follow this approach and you really verify your data at the source, then when you start to aggregate the data, it really comes, the integration really comes at zero cost. It comes naturally by joining the stuff together. So we really get rid of data transformation at scale. And just to give you a final example, that's the second last slide. I think then we also have some time for questions, I hope. So this is the model you've seen before in the tool, now in WebWall in a displayed way, where we have concepts like cell, tissue, gene product, protein, pathway, so the usual suspects. And here's one node that represents the gene variant disease association, where you have an associated gene variant, allele, and the associated disease, together with some evidence, statistical evidence that you can see here. We instantiate this ontology with data, building a knowledge graph. And here's the beauty of the approach. So on the top right side, in the black box, you see a snippet of the I2O knowledge graph, where you have a node representing a gene variant disease association with the associated variant of the disease and the associated disease itself. At the same time, we have a knowledge graph for competitor information, where I can say, okay, possibly I'm interested in this specific route, and now what I would like to know, what is the competitor landscape for this specific indication? And this knowledge graph here holds all the various products which are in the pipeline of all pharma. There's here the outer ring, and then you can expand a node where you see the drug type, which is a biological protein, as a mode of action, also has a licensor, and also you know in what developmental phase this resource is. And the join here between these two graphs comes for free, because this node, in this case it's a Parkinson's disease, has the same identifier. So really able to aggregate knowledge graphs without integration effort across our organization. So conclusions, if you want to be successful in digitization, we have to have true machine readable, true machine actionable data. And this makes the application of the FAIR principles mandatory. And if you want to be truly fair, then you're also tied into semantic technologies, as explained by the FAIR principles. So you have to use terminologies, data set definitions, ontologies, which are fair. We really can achieve transformation-less data integration built on fully harmonized and standardized machine actionable data assets. This is fair by design, prospective verification. And then you create a data ecosystem that creates more reliable insights in less time and at lower costs. We're also going into new architecture approaches in the around data and information management. And here again, I think the semantic interoperability is key. And I think I don't have to tell this to this community, but I think at the end of the day, all we are doing is related to semantics. So it's all about semantics. So thank you very much for your attention. And I hope you still have a couple of minutes for questions.
Thank you very much, Martin, for this amazing presentation. And we still have time for questions. We have 5 minutes for questions. Is there any question from the audience? It seems that you left them speechless. And I see hand raised. So there's Dermot. Dermot, please go ahead.
Thank you very much, Martin. Thank you for the excellent presentation. I came a little late to it. I have one question. When you develop the semantic layer, if I could call it that, how do you propagate that into the various systems and applications across Roche?
That's exactly the point. So I think we outsource the management of semantic resources in the system that I've shown to you, but we push it into the system. So for example, when we have an application that has a code list for diseases or for drug names or so on, they already store the GUPRIs. That's the key. So it's really been pushed down to the data layer. Nothing happens retrospectively, it's all prospectively.
Thank you very much.
Thank you. So I have questions. So how do you work with mappings in the end? So do you use SSSOM internally? Do you use the OXO service?
It's a blend. I mean, I think I would like to promote SSSOM more, right? I mean, imagine you could go to BioPortal or so. So we're taking a mixed approach here. What we have in the tool that I've shown to you, we have a UMLS plugin, so we can send a query, then get all the synonyms and all the mappings. And beside this, we have been maintaining a bot framework that goes, for example, to OXO and other resources to crawl mappings. But we also have a curation and a steward team reviewing these mappings because we don't want to create false positive entries. And I would be very happy if we could have an architecture where we can then feed back the results of our curation efforts into an open community. We don't have to do this for our own. I think really openness and shared fair architectures are quite important here.
Yeah, so I totally agree with you. Actually, I just want to give you 2 pointers. I don't know if you're going to be able to stay the whole day, but this afternoon you have colleagues from FairCore for EOSC and Fair Impact projects. These are 2 EOSC-related projects that are working on exactly this issue of mappings. So we are organizing a workshop, Fair Impact, next week on Thursday about mappings. And I know FairCore for EOSC is currently building a mapping registry to publish mappings and fair mappings. So
that sounds very interesting. Yeah, please keep me in the loop.
Sure.
Thanks a lot.
So there is a question from Amit.
Yeah. Hi, Martin. Excellent presentation. Thank you. A very quick question. Very intrigued by your last slide on the federated knowledge graphs. Can you just comment on in this case, the competitors' information? Was this all managed with the same, say, graph database, 4J, etc., or these were the knowledge graphs? Did they originate from different sources in terms of software?
Yeah, I mean, I have to say that we are using data here which comes from external commercial content providers. I'm also talking to them to push them towards a more fairer and standardized representation. And we are doing all the mappings and the integrations. But at the end of the day, we are currently just using one triple store technology in-house. So everything goes into, there are different instances, of course. It's not all in one, but we have different infrastructures. And this is really very appealing because then we really can build these infrastructures independently of other. And then if you have the Sparkle endpoints on top of it, the join comes quite naturally.
Yeah. Thank you.
Thank you, Martin. Actually, I just have a last question. How far is the integration of FAIR across the company? I mean, does it touch also the other business units like marketing, commercial? Did you manage to get that far?
I think this is a very important question because I think that so FAIR is mainly coming out of research and development so far. I mean, in particular research, we have a lot of fantastic resources. Development is also working on this because they have some standards which are mandated, which can also be made fair. Other areas are not yet so deep. And also my move that happened internally in the organization, now going more in the enterprise data space, is exactly based on this motivation. I think if you go to, let's say, the classical IT organizations, FAIR really doesn't speak to them. And say classical metadata, master data management systems are not fair. Also, different data cataloging systems, different data governance tools, they are not yet fair. So I would say, in terms of maturity and outreach, I would say that true fair implementations are still a small minority, even though people buy more into the concept and are very, very supportive to get this in place at scale.
Thank you, Martin. So I think, is there any other question from online or the audience? If not, then I propose that we move to the next talk, which is going to be given by Irlan Grangel, right, from BOSCH. Thank you very much, Martin, for this presentation. It was really enlightening.
Thanks a lot for having me.
Hello, can you hear me?
Yes, we can hear you fine.
All right, then I will
Irlan, to present briefly
yeah.
principles at BOSCH. Thank you, Irlan.
All right. Okay, thanks for having me here. And I entitled this presentation like Towards Fair Data Principle at BOSCH, because let me start very honest thing. It's not like we have already this whole implemented, but definitely we are moving towards that, because we realize the importance of that for our data world. So we are BOSCH, yeah, invented for life. You know that. I will not go into details, but I do want to express how big is, because even for us as BOSCH employees, like for example, Evgeny might be present here as well, it's also important to understand who we are, how big we are. We are basically active in mobility solutions, industrial technology, energy availability technology, consumer goods, and so on. And it keeps growing and extending. These are the figures of our company in 2022. Don't go into detail, just for you to know how, how many people, how many colleagues we are working around the world, how many subsidiaries, revenue, and so on. And where we want to go. So, and the distance where we want to go is not only this distance to the next vehicle using an e-bike and using artificial intelligence telling us something. It's even beyond. We really want to become an AIoT based company. And of course, in order to do that, we have to deal with data. And particularly, in my work, I'm focused on the so-called Industry 4.0 inside this whole set of business sectors we are tackling. And because BOSCH is a leading provider of innovative Industry 4.0 technologies and solutions. And but sadly, or unfortunately, this is what we have today. We have today many applications and many data sources or data silos. And some of our colleagues, of our management, some, hopefully not everybody, and now even more and more people are getting into the understanding of the principles like FAIR. But this is what the current situation we have in most of our cases. But we have a nice team working towards changing this situation. So the situation is as this. We have a mindset like, if we think, okay, we are doing an application, we get the data for this application and we're happy. But then next application, I don't have to explain this to this community, but I just want to explain the current situation we have. And the things, the challenges that we are facing. We are facing the issues regarding standardization, reusability, and most important, I really like the previous presentation, the end of the presentation was saying, okay, is everything about semantics? And that's why I also started with the presenting you how big we are, and I think also for Roche might be similar, because if you combine people from different mindsets, different countries, and so on, this gets even worse. But our CEO, he sees, and this is really nice, he sees the potential of semantic, and of course, in order to get to that, we really are working towards data first principle and understanding that semantic work on data will be the future. I also don't want to explain you that, but this is where we want to go. So we have a lot of data, really a lot. We have a lot of experts with a lot of know-how, knowledge on how to do products, processes, and so on and so forth. And typically, this knowledge is really, not properly encoded in a machine-readable way. In my experience, and this is something that might be interesting, something I want to mention is when you talk to the people about ontologies, they freak out, starting with that. Then if you talk about knowledge graph and you say, okay, Google has a knowledge graph, they change a bit, but still have some doubt. But if you talk about FAIR principles, in my experience in these last 2 months, it seems that the acceptance of the term is better than when you talk about ontologies and knowledge graph, which I am really using a lot nowadays. But this is where we want to go, and actually we start going. Yeah. So we are having all these data sources. We are proposing a knowledge graph-based data integration for actually bringing data, make sense out of this data, and then make the data and the ontologies public in a way that they can be, or they can follow FAIR principles. On top of that, we are also developing something called digital twin system and so on and so forth, that actually is also in accordance with, or hopefully, we are trying to make it accordance with the FAIR principle. And of course, nothing of this will happen without the proper data governance, which is really required for that. In this context, we are developing or pushing the organization toward the data mesh, data fabric way of thinking. And of course, in order to have a data mesh, I will show you later one concrete example, we need to be compliant with FAIR principles. But this is the approach that we, my colleague Evgeny here and others, we are pushing forward. Concretely speaking, if that's why I started with this, how big BOSCH is. If we we say, okay, we have to start with something concrete. We have to realize use cases. We have to show the power of semantics, ontologies, knowledge graph, and most of all, how important it would be for the company to have FAIR data. And we started with a so-called core information model for manufacturing, which is a set of ontologies we develop to tackle specific use cases, combining data from this, making, I don't have to go into details, having the mappings with a concrete triple store to actually build system on top of that. And I will show you an example later. So this set of ontologies, they combine different main, let's say, core entities and objects and relationships and classes particularly for manufacturing. They are based in the IEC 62264 standard. We keep on developing these ontologies as a part of the Industrial Digital Twin Association, and that which is there is a public part of these ontologies we keep on developing, and they are made available. A version of them, they are made available as a part of the Eclipse Foundation. I don't want to go again into details here. Just wanted to show you that, for example, these ontologies, they really tackle core concept when it comes to manufacturing knowledge graph. For example, everybody at manufacturing wants to define what is a machine, what is a physical machine, what is a machine component, what is a tool, what is a logical side, which becomes very, very complicated, what is an equipment, what is an area. And as a part of the FAIR principles, we are working towards making these ontologies available across the organization, meaning that we have already a place where the people say, okay, if I type in machine, I get the machine and I get the definition of a machine defined by the standard, and I can find where this machine is actually defined. Of course, if I have the right roles, I can edit, do changes, or do proposals for changes, but in the minimum way, I can view what this machine is about. Again, don't want to go into details, but the processes, for example, in manufacturing are key. All the people are looking into processes from different point of view. And again, one would like to be able to find what we meant by processes, and what we meant by processes that actually are really connected or tied to the product development. And all of this comes that are really defining these ontologies and made available so that our organization can access, at least now, the schema and ontologies definition. And of course, this all goes along the lines of, in order to have the FAIR principle is, applied or implemented, we really have to define. Okay, we start with a set of core ontologies, really like upper or core ontologies in the sense, defining really. I don't have to explain this to this community. I'm so used to explain to our colleagues upper ontologies, yeah. And these upper ontologies are connected to domain core ontologies. For example, manufacturing, as I was presenting, this set of ontologies, the SIM ontologies. They are connected, and also we have the use case or application ontologies, which at the same time they are connected to domain core ontologies. And this is very important because as again we are divided between these different business units, and sometimes we can reuse, or actually we are reusing these domain core ontologies across different use cases across different business units, but there might be specific things for a given business unit that is not the same or as the other business unit. And as in the previous presentation, here the definition of specific semantic terminologies is very important. And at the same time, we are providing, again, a typical thing in terms of ontology reusability, but we are providing the possibility for the concrete business unit to define what they need, and at the same time to be aligned with the domain ontology, core ontologies, as well as with the core ontologies. And all of this setting is made available in a central repo so that everybody can even see what other colleagues are doing in different business units. Concretely speaking, one of the use cases, and when I refer use cases, of course, this is what we can present, but this means that the whole process has been tackled, meaning we have data sources with data quality, which is a thing to be tackled. These data sources are then defined in ontologies. Again, I think I have to explain this, but the mapping process is very complex. We have tool in place to kind of, we have worked in this for last 3 years, but this is one of the use cases that is becoming part of the data mesh and the FAIR principle. I will show you in a minute. And for example, here we have integrated data from MES, from ERP system we have, from actual line capability, from product requirement. This is a real use case implemented, taking data even from departments that they were not used to talk to one another. And actually we did a whole thing, all this, put into a knowledge graph and make available and build an application on top of that. But we realized that this is a good thing, and actually solving a lot of problems. Most of the people they thought it was not possible to kind of do something like that. But this is not the end of the problem. We realized that if we don't make this data fair, then the effort we are doing to solve a specific problem, the usability of knowledge graph or ontologies and so on, would not be enough to actually really cover all the thing we need at BOSCH. So we realized that even though having use cases is the thing we have to go and have to do it now and do it well and do it in a way it can grow. If we don't follow FAIR principles, I mean, that's just might be completely understandable for the community, but we realize internally that if we don't follow FAIR principles, then the effort we are doing here will be somehow not completely understood by the organization. And for example, here we have another use case, which is actually very even more mature. It's a use case that is being used across 13 plants already, where we are actually integrating data again from different sources. We are putting this data into. We have specific use case ontologies, and interestingly, let me go back here. In these two use cases, we are reusing the same set of domain ontologies, the previous one I was describing, and making them available so that our colleagues can follow. At least we start with basic FAIR principle on that. So this use case here is actually enabling us to, second one I'm presenting here is actually enabling us to answer questions that were not possible to answer before this use case was done. But again, this was not enough. And even these two use cases were belonging to the same kind of business unit or organization inside the whole world of BOSCH. We realized that this was not enough. So just these are minor data about what we are doing. For example, just might be interesting. We really integrated more than 1,000 production lines, more than 16 physical machines, and a lot of also manufacturing processes. But, and here it comes maybe the main thing that we are actually working and very actively working. And I think workshops like this, it will be a pity not having more people from BOSCH in this kind of workshops. But it's great that you are actually driving this. Okay, so we have these two use cases. There are many more, at least in one single division, we have 4 of them. And we realize, okay, we have done the whole pipeline. We have understood the data sources. We have cleaned the data. We have created ontologies. We are reusing domain ontologies and so on. And here we are actually putting the products. We are starting towards the data mesh way of thinking, having the FAIR principles right on top priority. So we are, as a part of the FAIR principles, so far we are having 2 things. First, we publish the ontologies in a searchable way so that the colleagues can, and hopefully soon also the machines can get the concepts, definition, or the properties, and so on and so forth. And we are also making the data available in a way that the people and the machines can also find the data. And via these so-called data contracts, we are still defining what is exactly a data contract for that, because it also contains not only the FAIR principle, but also security is very important here. So it's very important because sometimes there are, regulations regarding data between countries, between continents, between even inside BOSCH, we have to deal with all these security things. But the principle is the same. We have built different knowledge, and we are now seeing them as data product that should follow the findable, accessible, interoperable, and reusable principle, as well as other, for example, security, and so on and so forth. We are defining to what extent they should meet these FAIR principles, and we are kind of putting the data products in kind of a data market. So they are, again, following the same principles. That is what I entitled that way. We are toward having the FAIR principles. We are not yet there, and I think any feedback, any input from your point of view will be really highly, or question even, that enables us to understand further what can be done here. And also we are thinking in having something like, that's why I also think this is WORSH is very important, in having something like a quality, how or to what extent or every data product should define FAIR principles, and which is the level of quality that we are tackling in every data product of from this FAIR principle, because we at BOSCH are very good and when it comes to the quality of the physical products we produce. I believe that I buy BOSCH products by myself, but I think we have to improve the way we treat data. I think maybe this is not only as BOSCH, but also every software or data related company. All right, I mean, I don't have to go into this. I think very important, or based on my experience, very important here. When we provide this data products, that we give this 360-degree view of data. So for some of our colleagues, even for this community, might be, I mean, trivial, but for some of our colleagues still is very impacting when we provide a knowledge graph-based data product that you can actually integrate data, put the semantics, put ontologies and so on, and make this available so that this can be reused, so that we can save a lot of time and money. We are involved in many domain experts, people that are very busy. They don't have time for nothing else but to actually do their stuff, and we are convincing a lot of our domain experts that this is very important for us. Reusability, impact on data quality, will not go into details here. And this is where we want to go and already started. I will already discuss about the full data fabric, data mesh, following FAIR principles. At least we started with making, started with a kind of ontologies, or making FAIR for ontologies, having central repo, way of finding the ontologies, and now we are working also with that for the knowledge graph-based data products we provide. We still have some issues when it comes to the use cases regarding the tooling and the scalability and performance, but I think this is something we are actively working on, and something that also active working on is providing some Google-like search on top of our knowledge graph-based data products that can be also linked to the FAIR principles. And last but also not least, we are also showing the value of all the things we are doing, also providing, okay, now one can do AI ML on top of knowledge graph, not only for improving the knowledge graph, but also to do actual prediction, machine learning, recommended, and so on and so forth. All right, that's the end of my presentation. Will be great if you can have some questions or suggestions and so on.
Thank you very much, Irlan. Thank you very much for this nice presentation. Is there any question for Irlan? Yep, there is a question.
Hi, thanks for your talk. I had a question regarding the involvement of domain experts. How hard is this for you to work together with with your domain experts to convince them, or are they, as you said, they are limited in time? And I think this is also the bottleneck in the project where I work in. That so I'm from the FAIRmat project. That the users, they want to improve their data and data quality and so on, and data workflows, but they have very limited time. It's really hard to get to a sustainable change.
Yeah, I think the most important thing here in my experience will be to show something that is actually bringing value for them. So of course, not only showing something that makes sense, which is of course the first thing when we talk to experts, but as soon as possible that one can really show, okay, if we go down this path, like really having FAIR principles and so on, this is the value you can get. I mean, of course, might take half a year, might take 1 year, might take even 2 years, but this is the value you can get. And then it's always good to I mean, in my experience, to show concrete values on top of the real data. I mean, I really work with data every day. And when I, for example, the previous presentation was just describing this semantics, interoperability, conflicts, and so on. So in my experience, has been very valuable to really show on top of the data that the experts they deal with, to explain them that Excel, not creating another Excel sheet is not the way. Creating another table, I have seen table with 1,000 columns, and they keep on growing. So really showing that this is not the way to go to deal with data, especially when in times that you have, you know, ChatGPT and this kind of stuff, that you really want to do something valuable with your data. So that would be my main, I mean, in my experience, the main suggestion I will give you.
And are you already capable of doing nice or easy to use solutions for them, or is this also a problem for you, like that they are able to use the stuff that you develop for them?
We have at least developed at least 3 products. I mean, at least 3 knowledge graph-based data products where we really, you know, we really integrate. We do the whole path. We really integrate data, put ontologies, make it usable, and so on and so forth. So it has been hard. It is still hard. But yeah, I think we have managed to do so, and there is a buy-in from most of the organization. So the people understood the importance of semantics, of data sharing, and I think, and something interesting that, again, I started with that in the presentation. It seems that the FAIR principles are more understandable for the people than even if you talk ontologies, everybody freaks out. But if you start with FAIR and then go to ontologies, it seems like easier to understand, yeah, in my experience.
Thank you. I have another question.
Yes, my name is Björn Johansson. I'm doing research on standardization and modeling and the data structure for digital twins and so on. And I have a question about the CIMM, the core information model manufacturing. Did you build it yourself, or is it a part of another type of standard or something like that? Or can you
it is based, I mean, we did not build by ourselves. Actually, there are other companies involved, and this is an open effort that we are driving also in this Industrial Digital Twin Association. So if you want to join, you can join. It will be great to have more people on board with experience in manufacturing. But again, to your question, this was built on top of the IEC 62264 standard. So it's not our idea. We just try to take the standards. I mean, when we started, our colleagues were doing the same, but in PowerPoints. And we say, okay, why not take in the PowerPoints, make this knowledge, I mean, usable in ontologies? And this is what we did. And actually, it is used in practice currently in the data products that we are developing. Yeah.
Thank you.
Thank you very much, Irlan. Now it's time to move for our next speaker and last speaker for that session on. Oh, there's another question. Oh, so there is another question. Sorry, I did. So, yeah.
So if we still have time. So I had a question. You showed 2 use cases. One was this line information use case, and I think that's let's say a limited amount of data you have there in your plan. So it's a lot of data, but it's somehow limited. In the other use case, you showed something about product manufacturing data, and Bosch is producing thousands of products per day and millions per week. And how do you handle all this data in ontologies or triple stores, or what is your strategy there?
Yeah, but again, we are not tackling the whole Bosch. This is impossible. So we are tackling one division, and out of this division, like 2 departments.
Okay.
Because if we start tackling the whole Bosch, I mean, no way. But we are making it grow, and actually, I was speaking about performance scalability. I think that in my humble opinion, the current tooling we have when it comes to actual scalability for triple store is still not the desired one, I would say. Yeah.
Okay, thank you.
All right.
Thank you very much, Irlan. So I would like to welcome now our next speaker, the last from this session on introducing FAIR principles and also implementation. So Dermot from Dynaccurate actually accepted to give another perspective, an entrepreneur perspective on FAIR. Dermot, floor is yours.
Thank you very much, Yann. So I don't think I have a huge amount of time. I'll try to go fairly fast. I actually suffered quite a conflict on this because when you look at the entrepreneurial environment and also when you take that look at the FAIR environment, they are completely different because entrepreneurs have to work in an extremely messy environment. They're normally building something which hasn't been seen before. That's the whole point of being an entrepreneur. You're trying to go to market with something relatively new or something that's been improved. Whereas FAIR is about, if you look at what FAIR is, you know, in its end state, it's quite utopian and extremely structured and very mature, you know. So you have this conflict. So what I'm going to be doing in this presentation, I'm going to be taking a pretty simplistic view of it, and but I'm going to try and show how when entrepreneurship moves through a sector, you kind of leave it more structured than when you found it. And you could probably also talk about innovation in the same way. So I'm going to take it from there. I don't have a huge amount of time, so my bio is up there, but just suffice it to say, we actually do have a product which does leave data in a fairer way than when we found it, and you know, we'll take in, I know, relatively unstructured data and you know, match it off against an ontology in the appropriate way, and it's very easy to use and you can really scale it. But so I do know what we're talking about in FAIR, but you might not think that by the way I'm going to present. Okay, right. Entrepreneurs are interested in possibilities, not principles, in the first pass, right? FAIR is perfectly sensible. And I would say absolutely it's the future, you know, and you'll see that in my conclusions later. But that is not the starting point for an entrepreneur. An entrepreneur is interested in pragmatic questions up front: market, need, price, investment. Those are the starting points for an entrepreneur. So we're assuming the entrepreneur is looking at, you know, some kind of data-based product here. They're not thinking of FAIR in the first instance. They might have it in the back of their mind, you know, kind of like, well, how's this going to scale if I want to make a business or something like that. But even when they think of that, they're going to think, how much is it going to cost? How much am I going to charge? Because, you know, FAIR is based on an economy as well. You know, data just doesn't become FAIR. It doesn't become FAIR like a mushroom grows. You know, somebody has to invest in it, and that comes back down to the market. So that's the first message I'd give you on the way entrepreneurs look at FAIR. And I think what would be useful for this audience as well, because I know all of you are, you know, quite expert in this field, much more so than me because I come from the business side, but try and also see this as an opportunity to see how the business looks at this. You know, they're going to be more like me in their approach to FAIR as it's described to them, you know. So let's try and look at it like that. Right, you all know these things, right? But I have them up just to give some kind of sense, just as a quick look to see what sort of things are expected, and then to come back, if I may say, to the reality of where you're starting off as an entrepreneur, okay? When it comes to findable for an entrepreneur, the first thing they want to find out is where that information is and who's going to give them access to it. So how can I get the information? And they're not maybe too concerned if it's split up between, or at this point, they're not too concerned whether it's split up between different applications or held in a central database or if it's structured, unstructured. Their first interest is what value they can get from that data. That's the first thing, okay? So the first pass of the findable aspect for them is extremely simplistic, and I would even go so far as to say is vulgar, right? So if I had data type A, so I've got that quote in the middle. If I had data type A, I could probably create an algorithm that would give me output B. Output B would be very valuable because, okay? So that's what they're thinking of in the first instance. So the findable for them is, where does this data exist? And this, the kind of the finer detail of that, they're not too concerned about at that stage, you know. So they know exactly what they're looking for. or well, maybe not exactly, but you get my message. They know what they're kind of, broadly speaking, in terms of data, what they're looking for. Now, accessible. This is the real interesting one. Now, there's various attributes there mentioned under accessible, right? Again, for entrepreneurs, it's going to be simplistic, you know. This is the make or break factor. Will you be given access to the data that you, at this point, you can say, you know, it exists, you know. Will you be given access to it? And that is just a simple yes, no proposition, you know, from the entrepreneur side. It's not maybes or whatever. It's like, is there criteria I have to satisfy to be given appropriate access? Okay, yes, I'm willing to do that, you know. And of course, certainly if it's sensitive data, that's absolutely going to be the case. If it's anything to do with people, yes, you know, so there's no question on the appropriateness, you know, that has to be factored in. But from the side of the provider, they're going to be thinking of, why should I do this? What's in it for me? You know, why should I assume this risk? Because in certain data sets, you could take, let's say, national statistical tables. You know, they're fairly straightforward. They're not particularly contentious. You know, but the more valuable data is data which hasn't yet been exploited. So, and generally that data hasn't been exploited for some reasons of either sensitivity or difficulty of accessing it or something of that nature. So you have to have a business case, you know, as an entrepreneur, to convince the business to give you access to the data. But thereafter, once you've given access to the data, there's all sort of questions is, you know, what is going to be the ongoing cost of that? You know, so again, if you come back to national statistical tables, there's an ongoing cost to producing those, keeping them disciplined. If you consider the use case of, or the case of Eurostat at the European level has to try and harmonize the data sets from all the member states on a progressive basis to get single uniform data. All of that costs money. Okay, so, and it's whether it's public or private is irrelevant. It all costs resources. So your business case is going to have to take that into account. And again, the finer aspects of the FAIR principles are all secondary to this at this stage, you know, except maybe, as I said before, the things around appropriateness of access, you know. So, and even when you have a very, very, very solid business case, there's absolutely no guarantee you'll get past this area, right? So you have to have a really good one, and you have to be really convincing to whoever owns that data. Interoperability. Now, assuming we've gotten past the accessible stage, this is actually where the finer points of FAIR can be implemented. Okay, so I just put up interoperable here to say, you know, the way it should be interoperable. In reality, what's going to happen with interoperability is, at this point, let's say you've been given access to data, you will probably now start implementing those kind of finer points of FAIR, because you actually have the data to do something with. Now you get getting to a stage where you can actually enrich it, okay? Because in the enrichment of this data, you know, whether it's through at the meta level or by identifiers or let's say the format of the data, you're adding value. This was actually the whole point of the business case, is by adding this value, whether it's just to prepare to exploit it, let's say with another algorithm or for AI or something like that, or even just making it shareable being the business case. This is where the rubber meets the road for the entrepreneur. Okay, now, having said that, it's not something that I would say, you can't make something universally interoperable technically and semantically just because, you know. And the point I would make here is you could make it absolutely interoperable, but probability is you simply don't have the resources for that. So what you are going to do is you're going to make it interoperable, whether it's technical or semantic, to a point. And you're going to stop that investment as soon as it satisfies the initial business case that you proposed, okay? That doesn't mean it's the end of the journey, you know, because as you mature data, it becomes more and more useful. It is a very, very positive cycle, assuming the data lend itself to that. Not all data is that useful. But it's going to be a kind of a stepwise approach, you know, and that's actually, I would say, super, super important. So the message I would give there, where there's a willingness to pay, an entrepreneur will find a way. I'll touch on this probably in the reusable aspect as well, because I think for me, these two are quite well merged. Reusable, you know, and the reason I'm dwelling on some of these is you see things like richly described, you know, with a plurality of accurate and relevant attributes. And this is absolutely appropriate. I mean, like, I totally support that. And we do our part on that as well. But when you read sentiments like that, you can immediately say this costs money, you know. So that's why FAIR has, you know, it has an investment requirement. So it has to have a corresponding business case to justify that. And seeing these, let's say, these characteristics of FAIR on the screen like that brings back to that point, you know. Reusable, right? So as an entrepreneur, again, you're market driven. That's just the way it is. So there's a few ways to look at reusability in this context. So if let's say you've got some kind of product or service offering which is FAIR related, and in the first instance, you may already have a commonly recognized industry standard which requires data to be in a particular format. There, you're absolutely going to be making that investment to conform to that, because otherwise you're just not being professional. You know, the market of professionals in that particular domain expect to receive the data in a way that is compatible for their industry. So that's the core reusability case. Having said that, it also comes back to that kind of interoperable thing. Reusability and interoperability for me would be very, very closely aligned. The question you have on that is how far you're going to go with it, you know. So in the first use case, you're going to have to go fairly far, I would say. The second reality, or the second area, is that, you know, you want to maybe expand the end users for the data that you're processing and improving. So that's when you might begin to make it, you probably will begin to make it available in new data formats for greater sharing and greater interoperability. You know, and sometimes the public sector will do that because they're trying to stimulate an ecosystem, you know. So first by publishing data, you know, openly, but also then making sure that the data has FAIR attributes so that it will have the most impact downstream. Sometimes a business might consider doing that if they also want to have an ecosystem element, because they want maybe, let's say, innovation to come in, and they're not quite sure where it'll come from. Maybe it'll come from R&D, maybe it'll come from maybe it will come from entrepreneurs, but they'll say, okay, if we put it out like this, it's going to have, you know, the most feedback that we can generate, so we'll make that investment as well. And then the third way to look at it is other reusability is the next guy's problem, right? And that's not, that is ruthless on one level, but again, it comes back to your resources and it comes back to your business case. But it's not as ruthless as you might think, because as each, let's say, use case or business case is put forward, you may have a scenario where the same data is being enriched to a new level, okay? But that new level had to be justified by the downstream use case or value to other people. So it might look very kind of truncated. It might look very, you know, somewhat selfish to not mature the data as much as you can in a fair way, but in reality is you probably won't be given that option, not unless you're very well resourced. And I would say as an entrepreneur, you probably won't get that at all. You'd have to be an employee in an organization which is heavily data driven and can understand and sponsor that kind of mission. But if you're outside of that, and actually all entrepreneurs by definition are outside of their clients' companies, it's not going to be like that. You know, you're going to mature to the level to where it sells. Either your product or your data is going to sell onwards, and that's that. You know, and if there were other use cases, maybe you'll get to them, maybe you won't, but maybe somebody else will. And over time, yes, you might have the same data in different places with all those nice attributes, but they're all split up, and you know, you want to merge it. But that's, for me, that is the natural order of things, you know. Open to be challenged on that, of course, and I hope I will hear some questions and statements at the end, but it's this is really, I would say, domain driven and context driven. So my final thoughts on this, I think we'll leave some time for questions. FAIR is entrepreneur friendly, but because the more data which is accessible and reusable and these things, you know, it's more opportunity. So, but of that, the accessibility is make or break. If you don't have the data, the rest is just academic, honestly. If you do have the data, then you have, generally speaking, you have to invest in it to give it the fair attributes, you know. But the more data, well, there's two sides to this. The more data which is fair, it means the more data which is mature. And if it's already mature, it means that other entrepreneurs have already been there, other entrepreneurs, innovators, or owners. And I would say if you know, if a huge amount of data was fair, we'd have a huge amount of automation. You know, so that's the way I would see this relationship, and this is the point I was making at the beginning. But fair is definitely entrepreneur friendly. Fair is a matter of ROI. There's no getting around that. Okay, it's just, you can say, oh well, it should be like this and it should be like that. It will be like that if it creates the value where somebody will pay for it. Okay, and there's no, you could talk about pretty much every improvement like that, but if you're talking about the private sector, that's literally the ROI. And even the public sector even the public sector cannot achieve everything it wants to achieve because they also have to go look for budgets internally. This one, I think, is the next point. Fair can be the byproduct, okay? And that maybe is, I would say, may not be initially obvious to everybody who's coming at this from the data science side, or if you're an employee in a company. But from the entrepreneur side, remember, you were engaged in the fair process to achieve another objective. Fair wasn't your first objective, you know. Your first objective was maybe to harmonize a data set, you know, for sharing to downstream, or so you could federate and train an AI or something like that, you know, and those are the kind of the objectives that you're after. But fair wasn't your first let's say instinct or your first interest. Your first interest was actually the downstream value which you were going to sell to the market. But in order to satisfy that, you invested in fair. So fair was the byproduct. And this is really a central message I'm getting across. This is how entrepreneurship creates structure where maybe it didn't exist so much before. And fundamentally, fair is absolutely the future. From looking at it from a business and entrepreneurship perspective, the amount of opportunity, the amount of efficiency, the amount of productivity that fair will give in the future means, for me, it's not, you wouldn't even question it, you know. Fair will definitely happen. So, and with that, I think I'll stop presenting and see Yann back at the podium, and I'll take any questions or comments.
Thank you, Dermot, for this presentation. Actually, it was very interesting because it's true that we usually see the general perspective of academia. We saw also the very interesting perspective from industry that now understand the value of fair and also the money they gain, and that actually relates to what you're saying. If you want fair, you need to define and determine the ROI, right? So they need to see the value that is created by verification. Of course, this takes time and education. So it's very interesting to see the entrepreneur perspective. So I really appreciate your presentation. Is there any question for Dermot from the audience?
Anybody wants to ask me, how do I get management to sponsor my fair project? Probably a good one.
Well, as you are an AI-driven company, right? So if data was fair, don't you think you will spare a lot of money in training AI?
Oh yeah, absolutely, absolutely, and that's the message we're trying to get out. I think one thing for us is that one of our key focuses is health. Okay, so the pharma sector, I think we already see has a really mature attitude towards fair. But health is predominantly public driven in Europe, which I don't have a problem with. I'm quite happy with that. But it lacks the competence of data scientists to understand those downstream benefits, because in health, people are looking at you as a person, and your information is administration later, even though they need the information to give you health care. But it's there's a big kind of cultural divide there, you know. So entrepreneurs, I see a question come in. Entrepreneurs Day starts to begin to include FAIR in the dev process. It's driven by your end clients. So ask your end clients, ask your market, you know, because it can be difficult getting clients in this kind of area because it is quite specific. So ask around, and then generally as an entrepreneur, ask around a lot in the communities where you expect people to buy the product, and they'll give you the feedback that you need. Participate in development of tools for knowledge translators. Sorry, somebody wants to rephrase. I don't know if it's a comment or a question. In the development of tools for knowledge translators. Could somebody?
Yeah, what I mean with that is that there is this current effort here in OntoCommons for creating or building infrastructures for knowledge translation that you pair challenge owners with expertise to translate, so it's suitable for the OntoCommons or ontology systems. Maybe that could be also the same for FAIR, that one can expand this, use the same methodologies, the same tool sets and such when it comes to support for proper implementation of FAIR.
Yeah, that's actually like a demonstrator, you know, so you show all stakeholders what the value is. Again, the problem there is the accessibility. If you're out in the wider market, absolutely. I mean, this is something else that's like all of these things that, you know, like OntoCommons, particularly OntoCommons, but also all of these other kind of, if you're an entrepreneur, you really want to plug into every demonstrator, accelerator, and every opportunity going. That's where you get your feedback. But the big problem is accessibility. You know, if people won't even give you the initial data to clean up for them and show them, that's a big problem. And you'd be amazed at how long you can be looking for that. I hate to say it, but that's the truth.
Thank you, Dermot. I think it's time to go to the coffee break. I feel everybody is... So I guess everybody gets tired now. So thank you very much, Dermot. Again, thanks to all the presenters for this first part of the session. We're going